Good morning, everyone. This is Murugan from KPR Institute of Engineering and Technology. I'm working as an associate professor in the Department of EC. In this video, we're going to discuss about some basic fundamentals of digital electronics. So, in this video, we will learn some basics of the digital electronics. So, digital electronics is a field of electronics which deals with the digital signals. That means the signals which is processed are generated using electronic circuits which are digital in nature. So the smartphones, personal computers and many communication equipments which we are using in day-to-day life are the best examples of our digital electronics. And also we need to know the basics of analog electronics. On the other hand, analog electronics which deals with the analog signals. So the basic examples of your analog signals includes your amplifiers, timing, wave shaping circuits are the best examples of your analog signals. So the analog signals is a type of signal whose amplitude can take any value in the given time range. For example, if you are taking a voice signal as an example, we are working with the output of some amplifier circuit which may vary between 0 to 10 volt. So in the given range, the signal may take up any value at any time. This means in the given range there are infinite possibilities. So such signals are called analog signal. Now in time domain, the analog signal could be continuous or discrete. This means in the time domain it may exist continuously or it may exist as a discrete time interval signals. For example, when you take the voice signal as a continuous analog signal, on the other hand, if you measure some temperature values with the time duration, it will exist like a discrete signal. So the time is continuous but the values are discrete in nature. So signals are analog in nature but it may take some continuous values or discrete values. So next we are going to discuss about digital signals. Digital signals will take either two values, either high or low. The signal should be discrete. The voltage levels are measured or referred as voltage high or voltage low. The high values are represented as ones and low values are represented as zeros. The type of signal what we are going to discuss is digital signals. It will take only two values. The fundamental for the digital signals is a binary number system where we will have only high value and low value. So, for example, logic high or high voltage levels are represented as binary 1 and logic low or low voltage levels can be represented as binary 0. So, in terms of voltage level, high voltage could be 5 volt or even low voltage, where low level could be 0 volt. But in reality, the logic 1 and logic 0 are represented by voltage range rather than a particular voltage level. For example, for any digital signal to be considered as logic 1, it is not always to be equal to 5 volt. And even if the voltage level is within a certain band, then it can be considered as logic 1. For example, if the voltage level of signal is within the 2 voltage to 5 volt, then it could be considered as a logic 1. Similarly, let us say if the signal level is within 0 to 0.8 volt, then it could be represented as logic 0. This means as far as the signal levels in the certain band, then it can be identified as either logic 0 or logic 1. And that's the advantage of digital system, because even If the noise or interference gets superimposed on the actual signal, then also as far as the signal level is within the certain band, then it is possible to identify the signal as either logic 0 or logic 1. Then there are plenty of advantages of your digital signal. They are very easy to store, then replicate and process. Then the accuracy is so high, and the fabrication of digital systems are very easy with recent advancement in the technologies, and it is easily scalable to a large value. So, but in the case of analog signal, it is very difficult to construct a circuit, and it is very difficult to get high accurate output. So we are converting all analog signal into digital signals in recent times. So it is done by using your digital converters, analog to digital converters. So initially analog signals are converted into digital using analog to digital converters, then they are processed, and again they are converted into analog form using digital to analog converters. So ADCs and DACs are very important in real-time applications. So next we will discuss something about digital circuits. These digital circuits, since the voltage levels continuously switches between the high and low values, they are called switching circuits. And using these digital circuit, it is also possible to perform several logic operations, where the output is high or low based on certain logic conditions. And therefore, there are also known as logic circuits. For example, using the digital circuit, it is possible to design a circuit which will turn on the fan when it is daytime and whenever the temperature goes beyond 25 degrees. So the logic gates are the basic building blocks in digital electronics, and there are several types of logic gates. So this AND gate, NOT gate, OR gate are the three basic type of logic gates, and using these three gates it is possible to implement any logic functions. Apart from that, there are two universal gates, and they are called universal gates because using any two of these gates alone it is possible to perform or implement any logic operations. Apart from all these gates, there are two more gates which are known as XOR gate and XNOR gate. So using all these logic gates is possible to perform different logic operations. And any logic operation which can be implemented using these logic gates can be expressed using Boolean expressions. And using Boolean algebra, it is possible to minimize the Boolean expressions. So this minimization of Boolean expression is also very important part in digital circuits. Because with the minimization of the Boolean expression, it is possible to reduce the number of logic gates which is required to implement certain logic operation. So in the upcoming videos, we will learn about different types of logic gates, how these logic gates can be implemented, sorry, used to implement your logic functions. In general, there are two types of digital circuits. One is combinational circuit, another one is digital sequential circuits. So these combinational circuits are the one where the output of circuit only depends on the present input, while in case of sequential circuit, the output of the circuit also depends on the present input as well as the past outputs. So we can say that these sequential circuit also have a memory element. So this flip-flop is a very basic sequential circuit which can store one bit of information. And using these combinational and sequential circuit it is possible to perform different logic operations. For example, the arithmetic operations like addition, subtraction can be performed using these circuits. And other operations like comparison, encoding, decoding, multiplexing, demultiplexing, storing, counting can also be performed. Then sequential circuits is a circuit where we can have output based on the present input as well as the past output. So digital circuits is basically depends on the binary number systems and binary codes. Then we need to understand about the logic gates, then Boolean algebra, then combinational circuits operation and digital circuits operation. So these are the fundamental things we will need to learn in digital electronics. So for everything, the base is number system. Deals with only two values where we are going to use binary number system which will deal with only zeros and ones. So another thing what we need to consider while designing is power consumption, speed, then delay. So when you increase number of logic gates, it will increase the output time duration, path delays, everything. So we need to design an optimized circuit using some logic reduction techniques. So we'll discuss the details in next video. Thank you. Thank you all.